this presentation, I will be discussing about two approaches of degradation modeling. One is using lifetime data and another is using a structural health monitoring data. So this is the outline of this presentation. First, I will give an introduction of these two approaches, that is lifetime data based approach and SHM based approach for degradation modeling. And then I will discuss what are the key steps in SHM based degradation modeling. After that, I will be discussing about different kinds of degradation model, and finally I will give conclusion of this presentation. So what is the classical approach of reliability assessment? So if you want to assess the reliability of a system, classically or traditionally, the approach is based upon the lifetime data, that is failure time data. So what you do, you acquire failure time data or lifetime data and then you fit a distribution. So you decide which distribution best describes this data and then you fit a distribution. For example, you can fit a Bible distribution, you can fit a gamma distribution or log normal distribution. So once you have this distribution, you can estimate the parameter of this distribution. So based upon the parameter of this distribution, now you can calculate different kinds of statistics. For example, you can calculate mean time to failure. You can also plot the corresponding cumulative density function or probability density function, and you can calculate probability of failure at any given point of time. So this is the classical approach in which you fit a distribution to the lifetime data and then you calculate reliability of system at given point of time in future. So now the question is, where we apply this kind of model for degradation modeling. So in cases where high reliability of system is not required, for example street lamps, in those cases we can apply this kind of approach. For example, in case of a street lamp, very high reliability is not required. For example, one or two street lamps fails, it does not have much effect. So that's why we can apply this kind of approach for reliability assessment. Also, where I have to take a decision on population level, so population based statistics is required, in those cases we can use this approach. For example, maintenance of mechanical components, for example bearings, we can use reliability based approach or lifetime data based approach for reliability assessment. In cases where we don't have highly skilled laborers or we have only the semi-skilled or unskilled laborers, in those cases we can apply reliability based approach or lifetime data based approach. In these cases, laborers only requires distribution fitting, and that can be done either in Excel or some handheld devices also. So they can fit a distribution and they can plan for reliability of the system or future remaining useful life of the system. So this approach is trivial in case where high level of skilled laborers are not available. So what is the disadvantage of this kind of approach? So first is, it requires lifetime data. In many cases you don't have the lifetime data because the system is very long life system. So we don't have the lifetime data. Other disadvantage, it does not differentiate between new system and relatively old system. So it treats both as equivalent, both same. So in other words, we can say it does not incorporate the current condition in the reliability assessment or degradation modeling. So this is one of the drawbacks of this kind of approach. This kind of approach is not useful where high reliability of the system is required. So these drawbacks can be overcome in case if we apply SHM based degradation modeling. So why we use SHM based degradation modeling or prognosis? If I have a long life system, long line infrastructure, for example bridges or buildings, in those cases we require or we will not have the lifetime data, so we require SHM based degradation modeling. Another example, design life of civil engineering infrastructures are very long and we don't have the lifetime data. So we have only one option, that we can install the sensor over this infrastructure and we can collect the data and we can monitor the system or model the degradation using SHM based approach. Wherever we have a high reliability desired, in those cases also we have to apply SHM based approach, because we cannot afford, for example, in case of a street lamp we can afford, but if I have a plane crash we cannot afford. So in those cases we have to apply SHM based degradation modeling. In many cases, operating and loading condition also changes. So in those cases, reliability based approach or lifetime data based approach is not useful. We have to incorporate the operating and loading condition into the degradation model, and this can be done only if I take the measurements from the system and I use the current information from the system in our model. That is, we can use a SHM based approach. Also, in some cases, before failure occurs, we use repair. So we will not have a exact lifetime data, and in those cases we have to use these repair actions into the model, and this can only be done if I use a SHM based approach. So SHM based approach is useful in cases where we want to incorporate the current condition into the degradation modeling. So what is the main idea of SHM based prognosis? What we do, we have infrastructures. We can have a civil engineering infrastructure, mechanical infrastructure, or any other infrastructure. So what we do, we install sensors. So this can be different kinds of sensors. They can measure response from the system. It can be temperature, displacement, vibration, or any other kind of response that is coming from the system. It can be direct response or it can be indirect response. So these responses are measured using the sensor, and once I have this data, that is data collected over the sensor, it can be taken either real time or offline. So engineer can go and they can download this data. So once I have this data, and this data can be analyzed in office and some model can be proposed, and once I have the model, based upon that model we can predict, and based upon that prediction we can plan the maintenance action of the infrastructure. So this is the idea of SHM based prognosis. So we can use different kinds of sensor to measure the system response, and corresponding we can make the degradation model. So what are the different kinds of sensor we use? So we can use accelerometer or vibration sensor that basically measures the vibration as a response and it models the degradation. Another kinds of technique that we can use, we can measure the strain. So that is a strain gauges. So we install a strain gauges on the system and we can measure the strain response. We can also measure the thermal infrared, and based upon that we can see what is the current condition of the system and we can model the corresponding degradation. We can also model the displacement. For example, in case of dam, we can see what is the crest displacement and we can measure this displacement with time and we can model the degradation of the dam. So these are the different kinds of technique that can be used for degradation modeling. So now we can summarize the key steps in SHM based degradation modeling. The first step is data collection, that is done using the sensors. So once I have the data, I have to pre-process the data, that is I have to do some kind of signal filtering, and then I have to extract a damage sensitive feature, and once I have this damage sensitive feature, I have to model the corresponding degradation and I can then assess the reliability of the system. So this is the major steps that is followed in any SHM based degradation modeling. The same is pictorially described here. So if you see, now here I have this damage sensitive feature often called degradation indicators. So these degradation indicators are random variable. Now once I have this degradation indicator, I can fit a model. Now these degradation indicators are a random variable. So if I project this path into the future, and this path, that is the degradation model prediction, it can be different kinds of degradation model, we will see. So once I project this, wherever this crosses to the failure threshold, I define corresponding time as the failure time. Since this is a random variable, my failure time or remaining useful life will also be a random variable. So in past, different kinds of degradation model has been proposed in the literature for degradation modeling. So what are the different kinds of degradation model? So this can be based on physics of the system, that is mechanics of the system, and those approaches are called physics-based degradation model. In other words, physics-based degradation model try to model the degradation process using some kind of physics or mathematics, and that models the degradation. Another approach is data-driven approach. In this approach, the sensory data that has been taken from the system is used to model the degradation. Next approach, in which we use physics as well as data both, those approaches are called hybrid approaches. Now, in some cases, we are not able to formulate a mathematical model. In those cases, we use knowledge-based degradation model for degradation modeling. Now, if you see the data-driven model, this can be generalized or generally divided into three parts. You can have a random variable kind of degradation model, or a stochastic process degradation model, or artificial intelligence-based degradation model. So now, furthermore, if I divide a stochastic process model, it can further be divided into two categories. Either you can have a continuous degradation model, or you can have a discrete degradation model. So in case of discrete degradation model, you divide the degradation into different states. So you can have a, for example, Markov chain process, Markov process, or hidden Markov process, are example of a discrete degradation model. Now, in case of continuous degradation model, we have different kinds of degradation model. We can have a gamma process and binary process that basically models the degradation as a continuous process. But discrete processes models the degradation as a different discrete states of degradation. In these cases, we can use Markov family process like Markov chain, we can use semi-Markov process, or we can use hidden Markov model for modeling these kinds of degradation. So in general, these are the degradation model that has been used in the literature, and we can use this model for future degradation modeling. Now, what is the major challenge in modeling the degradation using SHM data? One major challenge is what kind of model I am going to use. Whether I am going to use a physics-based model, or data-driven model, or a knowledge-based model, or a hybrid model. So this depends upon the system. Another challenge is what are the best damage sensitive feature. So how we extract the damage sensitive feature from the data that is coming from the system, and what are the best indicator of damage, that is another challenge. Now, how we incorporate the degradation model information into maintenance planning. So this is another challenge. Once I have the degradation model, how we extract the information and how we implement those information for maintenance planning. And finally, how we implement this degradation model information in real times. So this is the major challenge, because once you have the complexity, it is very difficult to deploy in the real time. So that's why this is one of the major challenges, how we implement this in the real time. So now I will illustrate these kinds of degradation model. The first is data-driven model. You have two types of cases. You can have a continuous data-driven, or you can have a discrete state data-driven model. So for example, this shows a data-driven model. In this case, this is a gamma process model. This is an example of a stochastic process, and this is a random variable degradation model, and that is in this case linear. You can have a different kind of functional form. You can have a non-linear functional forms also. In case of discrete case, you can have a markup process. You divide the degradation into different states. So in this case, S1, S2, S3 denote the different states of degradation, and A is the transition matrix when the system is going from a state 1 to a state 2. If you are not able to observe these states directly, we can use hidden Markov model. In those cases, indirect observation can be used to model the degradation using these probability matrix A, B, O, and where S denotes the hidden state sequence. So either you can use Markov model or you can use a hidden Markov model to model the degradation in case of if you want to model the degradation in a discrete state. So next kind of degradation model we have that is based upon the physics of the process. One model that is widely used in the literature is Paris crack growth model, and this is based on the fracture mechanics. So this model can be described like this. So dA by dN is equals to C times delta K raised to the power m. Basically in this model, dA by dN is the fatigue crack growth rate, and delta K is the K max minus K mean, that is the stress intensity factor, and different constants we also have. A is the crack size and N is the number of fatigue cycles. So if you see, using this expression we can calculate the crack size A at any given fatigue cycle, so number of fatigue cycle N. So if I know the number of fatigue cycle, I can predict the crack size. So this is one approach, that is using the fracture mechanics we model the degradation process and we can predict the future crack length. So next kind of degradation model is hybrid model. This basically uses physics as well as data both. So this uses both kind of approaches. So basically take good from the physics based and also this takes good from the data driven. For example, in case of dam response measurement, we have one model called HSTT model, and this model basically uses physics as well as data both. This model is a basically superposition of different terms, and this model can be shown like this. Now in this case, by denote the dam response, and these are the different responses: environmental responses, hydrostatic, seasonal, temperature and age, and we assume using the linear behavior. So we are using some physics and we are applying the superposition, and in this case these terms can be given in terms of polynomial and sinusoidal functions. So these ideas are coming from physics of the process, and then we use data to calibrate this model. So this is an example of hybrid model. So where you are using some physics of the process as well as some or little bit of data to calibrate this model, and in future you can use this model for prediction and reliability assessment. And finally, the knowledge based model. So this kind of model is used where you are not able to make a mathematical accurate models. So we use the knowledge, and that's why this is called knowledge based system. So this is essentially composed of two subsystems. One is knowledge base and another is interface engine. Two kinds of model that has been widely used under the knowledge based model. One is called expert system and another is fuzzy logic. So these are very simple system that uses if then loop, and then you can implement in the real time or the practical cases for degradation modeling. So this is widely used in the literature as well as in the practical industry. So these are the different kinds of degradation model that we use for modeling the degradation. Now, how we estimate the parameters of this model? So two approaches we have. We can either use a maximum likelihood approach or we can use a Bayesian approach for parameter estimation. So in case of Bayesian approach, we use the Bayes theorem and then estimate the parameter. The advantage of this is, in case of Bayesian approach, if you don't have the data, you can still give the estimate of the parameter, and this is based upon the prior information. So as you have more data, you get the likelihood and then you club together or basically integrate together and you get the posterior distribution of the parameter. So this is a good idea in cases where you don't have the data, for example, long life civil engineering infrastructure or mechanical infrastructure where you don't have the data, we can use Bayesian approach for parameter estimation. So this shows prior and likelihood and then you get the posterior distribution of the parameter. So what are the conclusion of this presentation? So we discussed two approaches. One is reliability based approach, another is SHM based approach. Reliability based approach is good where you require a population based decision. You don't require high reliability. In those cases, we can use reliability based approach. In case of SHM based approach, if I have a system that is a long life infrastructure or high reliability is desired, or we require a condition based maintenance, in those cases we use SHM based approach. And we discussed four kinds of degradation model, that is a data driven model, physics based model, hybrid model and knowledge based model that can be used for degradation modeling. In future, we have to see how these models can be implemented in the real time. Moreover, how we filter the signal, how we extract the damage sensitive feature, and that can be more useful or more sensitive to the degradation of the system. So this is the presentation. With this, thank you.